Hi guys, this is a video that's a follow-up to a video I made a couple of months ago on servo testing. And in that video we tested, I think it's 4 different servos, and one of the criticisms was that it wasn't an overly scientific test, which I did sort of agree to in the video itself, but I thought let's make a more scientific video, I guess. So this is actually my second attempt at recording it, because the first one didn't have any sound, and this camera isn't brilliant, so sometimes I lose focus on stuff like this. So when I was trying to do an audio overdub, I couldn't actually read the screen, so let's record it again. Right, so let's go over the setup. At the start we have a 4S graphene battery. That will give us 14 volts. We're not going to use all of it, but it will give us plenty of power. It's just going through this, which is bloody useful for binding free sky stuff. It's just a simple on-off switch. That goes into this UBEC, which actually it's focusing better now. It can be switchable from 5 volts to 6 volts to 7.4 volts, so we can test some high volt servos with this. This is where the first time I recorded it, I used this Turnigy servo tester, and it actually caused issues on some servos. Like some of the digital servos, it would induce jitter, which I didn't actually get when I started using this. So yeah, that voltage comes out of the UBEC into the L9R, and then out of that into these two bits here. So we have a power and a ground, which powers this unit, lights it up, and the yellow cable is actually a voltage sense cable. So basically it will tell us how many volts are coming out of the L9R. The other two cables, the other cables, we have the positive that goes off to the servo plug. We have the signal that goes off to the servo plug. But if you notice, the negative, when that returns, it actually comes back, goes through this shunt resistor, and then into the L9R. And what this will do is it will allow us to read the amps. So we'll actually see how many amps are being drawn through the servos in general operation, and also when it's pulling on this thing here. This is a luggage scale. It'll go up to, I think, 10 kilograms. So it's more than what we need. But I got this because it had the hook on it, so I'd be able to pull stuff. But this linkage itself is pretty heavy. This is a rod I made up for an S800. So this metal at each end, it's carbon fiber rod in there. So it's solid, it's not going to bend. So it will give us good results, but it in itself is heavy. And the pull on this will not take into account. I mean, it's fair enough, it's only going to be a few grams, I guess, but it's something that's not going to be taken into consideration by the scales. That's what I'm getting at. It's just two little hooks that I use to sit the servos in. So what servos are we going to test? The first thing we're going to test is this. This is the Banggood TowerPro MG90S, which is a metal geared analog servo. It's rated at 4.8 and to 6 volts. So we'll be testing it at around 5 volts and 6 volts. What you need to do is get the specs back up. So, right, so at 4.8 volts, it will pull 1.8 kilograms per centimeter. And at 6 volts, it should pull 2.2 kilograms per centimeter. we're not worried about the speed on this test. I think it's negligible, to be honest. Most of them are similar sort of speeds. You do get some that's quicker and not, but I'm not going to worry too much about it. Well, I've got nothing that can measure it accurately, so it will just be a visual thing. So instead, we're going to stick with science for this one. So the other thing that I'll divulge, if I can get my arm around the microphone cable, is all the servos are being tested as close as possible to 1 centimeter away from the pivot point. So as you can see on this one, it's slightly outside it. If I do have to go slightly off, it's going slightly outside, which will actually mean that the results are slightly worse because it has less the closer you get it, the more torque it's got, basically. So it has slightly less torque, but it would be a bit faster. Right, so what I'll do on the first one is show you how I put this lot together, which is really not rocket science. It's just a little 3D printed mount I made, so I could put servos in the glider and get them out easy. It needs a bit of modification, but it will do the job for this. Sorry, I was actually going to say about what servos we were testing, and I've started testing this one. So what I'll do is I'll get this hooked up, and then we'll have a quick review. So what I will be testing, bear with me 1 second. Right, I will be testing the EMAX ES08A II, which is a plastic geared servo. But I've got it here, so why not? We'll see what that's capable of. So quick specs, 4.8 to 6 volts, which all of the servos apart from one I'm testing have this range. It's 1.5 to 1.8 kilograms, and it's an 8.5 gram servo. So the reason to use this one over the metal geared is weight saving, basically. This one is listed at 13.4 grams. Wonderful focus on this camera. Come on. Oh, forget it. Right, the next servo we'll test is the EMAX ES08MA II, which is the same servo effectively, but it is metal geared. So it's still an analog servo, and it's got slightly better torque ratings at 1.6 and 2 kilograms. So that's the next one we'll test. What I also have is the ES08MD II servo, which is the same as the last one, only it's digital, has the same specs, same weight at 12 grams, and the same torque specifications, but it's digital, so we'll check that. The next servo I'll test after that is this one here, which, if you give me a second, is the Banggood TowerPro fake. This is not showing up at all. There we go. MG90D, which it should be the same as this, but digital rather than analog. So same size. I can get the specs up when we actually do that servo. So let's put that there. After that, we should be testing again another EMAX, the ES3352, which is a 2.4 kilogram, or 2.4 gram metal geared digital servo. Again, it's 4.8 to 6 volts, but the torque rating on this is massive compared to the others. It's 2.4 to 2.8 kilograms. When you think the strongest on these have been 2 kilograms so far at 6 volts, this is supposedly beating that on 4.8 volts. And the speed of, yeah, the speed is comparable, it's the same. So that will be tested afterwards. And then finally, we will be testing the DS939 high volt virus servo. So the specs they give you, I have no idea what voltage they're rated at. This is a high volt servo, so it goes up to 8.4 volts. It's just listed the torque at 2.8 kilograms per centimeter, but it doesn't tell you what voltage they measured that at. So you'd sort of assume that it's at the highest voltage, so they give you the best specs possible from this servo. And the speed at 0.2 is actually, 0.12 is about the same as all these on 4.8 volts. So maybe this is at 4.8 volts. Regardless, we're going to test it at the 3 voltages we can test at. So they are the 7 servos that we'll be testing. So let's get on with it. So what I'll do is, let's get those out of the way. I'll take you through how I'm going to set all of these up. So I need my Tyrannus.
This isn't flying, this is falling with style. Throttle warning. Switch warning. Throttle disarmed. Throttle armed.
All right, let's turn the sound off on that. Right, so I've got it set up on the throttle. So it's not actually registering any amps at all. Oh, there we go. 1.26 with nothing attached. And that's being used all the time, which you're never going to do in flight. It's going to be more that sort of thing. You know, if not mostly that. It's never going to be that when you're flying a plane, is it? But anyway. So we'll get that. I don't need to worry about centering, but I do need to lengthen this off a bit. So we want it to be a little bit slack. All right, that should be about right. What I'll do in the remainder of the video is get all these set up in the same way. Did I use this? Yes, I did. Third hole out. So there we go. It's got a bit of slack. So then we'll switch that on and get it zeroed. Which, when the blue light goes out, you should see it better. And then what we'll do is we'll whack it full over and see what amps and kilograms we can pull. So amps 4.9 and about 1.6 kilograms. It's locked out at 1.58, but I'm sure I saw a 1.6 peak. So yeah, that's quite high. So it's 4.3 amps that time, but yeah, I definitely saw that peak at 4.9. So what I'll do is we'll now switch that off, and we'll move that up to 6 volts. Switch it back on again, reset the scales, and do the same again. So 4.5 and about 1.9. Let's get another reading on that. Yeah, it's about 1.9. So slightly under spec, because they said about 2.2. But yeah, quite a high amp draw. When it's, I mean, obviously when it's there, it is stalling. So normal servo movement is not going to be that. But if you get a servo that locks up, that's the sort of output you're looking at. I mean, But yeah, so 1.945 we got on that time. So it's a little bit under spec. What I'll do is I'll make a table that I can put up at the end of the video to show all the servos together. But what I'll do now is I'll pause it and then we'll come back with the next servo in our test. Right, so we're back with the EMAX ES08A II analog plastic geared servo. So what I thought I'd do is, again, we'll just have a play about with nothing attached and see what the average amps we get are. So about 0.8. Again, you're never going to be flying like that. So about 1.13, but yeah, it's going to be less than half an amp for general flying. So let's get this hooked up and do our pull tests. There we go. Right. 4.15 amp and 2.2 kilograms. So that's pretty decent. So we'll try that again with 6 volts. That was on 5 volts, so it should be more with 6 volts. So reset. 4.67 amps and 2.6 kilograms. That's pretty impressive. That's well over spec. Because I didn't actually show the specs, which rookie mistake. So here's the box. So as you can see, or not, there we go. It should be 1.5 kilograms and 1.8. So yeah, that's doing brilliant things. If it doesn't strip the plastic gears, that's going to pull like a tank. So yeah, I'm impressed. On to the next one. Right, so we're back with the ES08MA II, which is basically the same as the last servo, only it is metal geared rather than plastic geared. It's 12 grams rather than 8.4 grams, and it's rated slightly higher at 1.6 and 2 kilograms. So let's have a look. So let's do a it's saying 0.9, but again, are you really going to be doing that with a servo? I think, yeah, I mean, looking at this, I think if for standard flying you allow half an amp per servo, you'll be absolutely fine. You're never going to use over that. But let's get it hooked up, see what this does. Because again, this will be stalling amps. This is not what, you know, your control surfaces, unless when you set it up mechanically it's not going to be doing anywhere near these amps. This is just worst case scenario. So let's have a go. 4 amps and 2 point, it was 2 point something, but we'll wait for it to lock out. So yeah, 1.195. I'm just going to write these down. 1.995 even, so pretty much 2, and that was at 4 amps. But yeah, seeing as that was supposed to be 1.6 kilograms, again it is over spec, which we like. It's good. So see what we can get on 6 volts. 4.6 amps, 2.5 kilograms. That's stuck at that as well. That's brilliant. So 2.535 kilograms. So that is pretty much half a kilogram over spec. So yeah, really good servo. So yeah, I would, at the moment, EMAX is looking like it's winning. The TowerPro is an alright servo, don't get me wrong, but it's under spec. You know, it's saying it can do 2.2 and it can't. This is saying it can do 2, or sorry, it's saying it's going to do 1.8 and it's doing 2.5. So there's no contest there. One thing that I did get as a comment in the last video is that these aren't actually metal geared servos. It's only the top that's metal geared and the rest is plastic. I can assure you that that is 100% not true. If you found that, I would say that you've been unfortunately the recipient of fake servos. Well, not this particular one, but I've had one apart before. But if I've got the right screwdriver, we'll take it apart again. That's the one. So yeah, this is a genuine EMAX servo. They come with little scratchy sniff things on, and you can. I've actually not scratched any of those off because I trust the seller so much. But in the past, I have scratched the stuff off, and you put a code in on the EMAX website, and it says either yes, these are genuine, or no, these aren't. A lot of manufacturers are doing that now, like Sunny Sky are doing it with their motors. EMAX with their servos, and I think Foxeer are doing it with their cameras. I'm not having much luck with that screw, so I might have to find another servo. That one's loose, that one's loose. Maybe that one's rounded. Let's see if it'll come apart. I'll put a bit of pressure on it. There we go. There we go. Right, so I don't want anyone putting a comment under the video saying that they're not metal geared, they're plastic. Because as you'll see, absolutely every gear in this thing is metal. Or maybe you won't see because my camera won't focus. But I'm pretty certain even without the focus you can see it's shiny, brassy coloured. It's not white plastic. None of it is. It's all metal. So pop that back together. And I won't make you watch me screw it up. When we come back, the digital version. Right, so this is the ES08MD II, which is the same as the last servo. The only difference is this is digital and the last one was analog. The torque specs, the speed specs, the weight, everything is identical. Yeah, while I've got the box, as I say, it's got this bit here. You just scratch that bit off, and underneath there is a code. You go to this website and you type that code in, and it will tell you if they're fake or genuine. As I say, I don't bother checking anymore because the supplier I get these from, I'm perfectly satisfied that they're all genuine, because every single one I've checked from every single product that I've ordered from them has been spot on. But anyway, back at 5 volts, and let's just do the standard movement test. So standard movement, again, it's around about half an amp. Less movement is less. I mean, if you're only just doing subtle aileron changes, you're like a tenth of an amp. It's nothing. So it's not like you're going to be doing that when you're flying. I really should stop saying that every time I test a servo, but it's true. It's going to be very, very subtle movements. I think if you allow half an amp for each servo, then you're going to be fine. I mean, technically, if you've got if that's all that's being moved for most part, unless you're doing like tricks on sport planes every so often, then you might want more amps. But on a regular sort of, you know, four servo regular plane where you're just flying about gently, then a 3 amp servo would probably, or 3 amp ESC or BEC would be absolutely fine. It's not unless you are going to be doing more aggressive moves that then maybe you've got 4 servos, go for a 5 amp. Because as I say, the stalls that you see and the high figures here are going to be worst case scenario if something snags and gets caught, or if you're flying aggressively and you've got a lot of wind that you have to combat, then maybe you want to go for a higher amp servo. Like for example, I mean, and again, these are only 9 gram, so bigger servos obviously need bigger BECs. But yeah, in the mini drag, I'm running a 10 amp BEC for 2 servos, so basically 5 amps per servo, which, yeah, it shouldn't ever need, but it will give it plenty. So I think what I'm going to do for this one is actually shorten this slightly. Sorry, I should have done this off camera. And now we can test. Alright, let's have a look. 3.9 amps and 1.6. 3.9 and 1.6. So the amps are actually the same pretty much as with the analog version, but the kilograms is a fair bit less. The analog was 1.995, whereas this is 1.675. But it is still bang on. That's actually bang on spec. So you're not actually losing out any. But what you'll probably find with the digital is it's a much more precise servo. That's the difference. So yeah, bang on spec. And let's see what it does at 6 volts. So if it's bang on spec, we should be getting about 2 kilograms. All right. Let's get that reset properly. There we go. Right, so let's have a go. 4.36 and 2.2. Right, 4.36. It's actually slightly less amp draw than the analog, so we've seen that on both. And 2.2 is over spec. So again, it's the numbers on the box are actually pretty much what you're getting. Apart from 6 volt, you're getting slightly more. And with regards to amperage, it's using slightly less than the analog. So you wouldn't be disappointed if you went by the specs on the box. Not by a long shot. I think it's stranger that the analog one had such big gains for both of those 2 servos. But yeah, on with the next one. Right, so we're back with the MG90D, and this one, if you believe the specs, has got a pretty impressive spec. At 4.8 volts, it's saying it can do 2.1 kilograms of torque, and at 6 volts, it says 2.5. Now, we've had those figures with the EMAX analog plastic geared servo, so you never know. But the other TowerPro was under spec, so let's give it a quick. Yeah, so again, we're seeing similar sort of numbers for regular flight. If anything, slightly lower. So yeah, that's not bad. So get that hooked up. Let's get our scales zeroed. And let's see what we can do. This is at 4.8 volts, 5.2 amps, 2.9 kilograms. So 5.2 amps is the highest we've seen so far. But 2.905 kilograms is well over spec. That's incredible. That's pretty much what is 0.8 kilograms more than the specification states. That's impressive. So let's zero that and let's see what we can get with more power. So there we go, 6 volts, 5.6 amps. Oh, and I saw a peak of 3.5 kilograms there. That was amazing. So I'm gonna record the locked number because that's what it consistently held. But there was definitely a peak of 3.5. So that's 3.465 kilograms. So that's, you know, with the peak of 3.5 kilograms, that's a kilogram over what the specification says. That is brilliant. that is a fantastic servo. Yeah, well within spec, well over specs. Unlike its analog brother, the MG90S, which was underwhelming. It's it's a good cheap servo, but I think for the extra little bit of money, you can get something so much better. And yeah, that TowerPro, ooh, that's impressed me. That's the highest numbers we've got so far. So let's see what the slimline EMAX can do. So this is what we'll be testing next, which is the ES3352 servo, which from those dimensions, it's looks like a regular 9-gram servo, but you flip it on its edge, it's 10 millimeters deep. It's a really thin servo, and this one, the specs are 2.4 and 2.8 kilograms, which, for something that thin, that's pretty impressive. If it does it, let's have a look. And we're back with the EMAX ES3352, which I'll just grab a box for. So there we go. Again, it's 4.8 to 6 volts, but as you can see, 2.4 to 2.8 kilograms. It's a 12.4 gram servo. They're massive specs for something this size. Now, one thing I will say is it's a bit wobbly. Where it's a thin servo, and this little rig was made for 9-gram size, I've had to shove some EPP underneath, but it isn't as secure as the other one, so we might see a little bit of discrepancy because of that not being in properly. Also, this hole is slightly further away than 1 centimeter, so that will also reduce slightly the results. But let's do so it's actually, even at subtle movements, it's quite a high amp draw on this servo, which is maybe why it can do those high power pulls. That's significantly higher than we've seen other servos do for similar subtle movements. So maybe with these servos, a slightly higher powered BEC would be an advantage. I mean, if you've got 2 of these in a wing, 3 amps would probably be fine. What are we getting with high movements? Also, the top end is not bad, but subtle movements is higher than average, but there we go, 2.6. But yeah, so maybe have a bit more power in your BEC with these servos than you would otherwise have. All right, so let's get us all ready. Let's go. 5.32 and 2.35. All right, so let's go. So 5.32 amps. So it's not far off of the last servos, and 2.295. It did go slightly up to 2.3, but even so, that's slightly under spec. It's supposed to be 2.4, and we're getting a approximately 2.3. So it is slightly under spec. So let's have a look at the 6 volts. It's still pretty impressive for the how thin the servo is. And again, also maybe that tiny bit is getting affected because it's getting slightly less torque because it's further away than a centimeter. I think it's about 1.1, 1.2 centimeters. So that it could be on spec, and it's more this rig that's doing it. But anyway, let's see what we get here. So 6.19 and 2. There was a 2.7 there. So 6.19 amps, which is the highest amps we've seen, and I'll record the 2.685. But yeah, I definitely saw a 2.7, which again, the difference on the amount of torque there may be what's causing that. So on average, I'd say that is on spec. It is a very current thirsty servo. That's what I'm taking away from this. I'd say it's on spec, but be careful with your BECs. Right, and then we're on to our last servo. Right, so we're on to our last servo, which is the SARS DS939HV servo, also known as the coronavirus servo, which has a rating up to 8.4 volts because it is a high volt servo, and a torque rating of 2.8 kilograms per centimeter. We don't actually know, sorry about the focus, we don't actually know what voltage that rating is for. I mean, is it at the 8.4 volts or is it at 4.8 volts? And they're giving you the worst case scenario. At the 0.12 is what the EMAX was doing at 4.8 volts. So if that's at 8.4 volts, it's going to be quite a slow servo. But what we can do is have a look. What I will say about this servo is, because I've used it before, and you will see on the other test video, is when you go up to the next voltage up, it actually adjusts where the center point is. So if I center it now, that is actually center at 5 volts. And you can see the range, that's pretty much flat, and that's going forward slightly. So from there to there, well, 90 degrees is there, so probably about 120 degree range. So what we'll do is let's have a quick look at the average draw. About half an amp. Let's get it hooked up again with this one. That's a bit tight, I'm gonna have to loosen that off. With this one, the results may be slightly skewed against it because the hole is slightly further than a centimeter out. So we won't, we'll give it a little bit of tolerance, even though we don't actually know what that 2.8 kilograms was for. Right, so let's go. So it's 3.16 and 2.5 kilograms roughly. So 3.16 amps and 2.425 kilograms. Yeah, as I say, unfortunately, we don't know how close that is to spec because we don't know. All we can do is go up to the next voltage and see what that's like. That's actually got a little bit tighter going up the voltage. But regardless. The other thing of note with this servo is that it's actually reversed compared to the other servos. So before, on all the other servos, this way has been full throttle, that way has been no throttle. It's actually backwards on this. Not that it will probably make much difference, but just saying. Right, so let's go. 3.68 and 3.1 kilograms. That's pretty impressive. So I saw 3.25 there as well. So 3.25 amps and 3.115 kilograms. So that's pretty impressive. What I'm going to do now is show you the difference at 7.4 volts. So let's reset you. Alright, so at 7.4, if I center it now, you'll see it's over this way. Interesting. That's actually the same as it was before. When I was doing it before, and it was the center point was changing, was when I was using this Turnigy servo tester. Going through the proper receiver, it's no difference. Right. So that's one bad or negative gone, because going through a receiver, it's actually, same sweep, same center point, everything. Before, the center point with this thing at 7.4 volts, the center point was changing. I've just seen that this is only rated to 6 volts. That'll be why. Okay. The L9R is rated to 10 volts, so that's absolutely fine. But let's zero U again. That is slack, so that's fine. Right, let's see what we do now. So it's 4.47, 3.64 kilograms. Let's just make a note of that before I forget. 4.47 amps and 3.640 kilograms. Which again, it on the box it says 2.8 kilograms. So if that was at 4.8 volts, it's actually under spec slightly. But then if it was at 8.4 volts, it's going to be quite a bit over spec. I'd imagine, looking at these numbers, if you add this is 7.4, so the extra volt, you're probably going to go up to around about 3.8, 3.9 kilograms of torque at 1 centimeter. So yeah, that's quite impressive. I think half the problems I've had with previous servo tests have been from this thing, because this servo, when I was testing with this servo and the ES3352, they were jittering a lot. So was the MG90S slightly at 6 volts. But with this thing, they were jittering all the time. And I mean, the 3352 only goes up to 6 volts, so that's within spec for this. But what I'd find is I'd put it on, say, this mode, and you'd get 2 LEDs lighting up. I don't think it could handle the digital signal properly. So this is gone from the test rig. That's using a proper receiver is definitely the way to go. So yeah, the results from the first test are completely null and void pretty much because of that Turnigy servo tester. There's no jittering whatsoever with this thing. It's absolutely perfect and well over spec. So what I'll do now is I'll get this put away and we'll have a look at the figures and see what results we can get overall. Okay, so here we have the test results. As you can see, most of the servos actually performed slightly better than their ratings. The only one that didn't really was the TowerPro MG90S, which at 6 volts only just really matched what it was supposed to do at 4.8 volts. So that's the only real disappointing servo that we have on here. Everything else, apart from the EMAX ES3352, don't forget we had a slight issue where the torque was going to be slightly down on what it should be anyway because of the servo hold position. The same with the Corona DS939HV, but that actually performed better than expected. So yeah, overall, most of the servos that have been on test have by far exceeded, well, not by far, but have exceeded their expectations. The one that did by far exceed was the TowerPro MG90D, which the specs on that are phenomenal for what it's rated for. We're talking, 800 grams more at 4.8 volts than it's rated at. And again, 900 grams or 950 grams more at 6 volts than it's rated at. That is a phenomenal servo with regards to torque. There may be questions with reliability, but from what I've heard from people who use them, it's not an issue at all. It's actually a really, really good servo. So that's pretty much where I'm going to leave it. There's the results. You can use them as you will to choose which servos you'd like to use on your aircraft. As I say, the takeaway from this is with the MG90S, you basically pay for a cheap servo, you get a cheap servo. But for the extra, little bit for the ES08MA II, you'll actually get a far superior servo for not much more money. There we go. If you've found this video useful, I'd love it if you'd subscribe or give me a thumbs up. And if you found it really helpful, if you click the bell icon, you'll get a notification next time something comes up. So yeah, thanks for watching. What I will actually do while we're here is advertise the Facebook group. You can find it at Facebook under Fixed Wing RC Rebels. And everyone's welcome, no matter what disciplines you fly, as long as it's fixed wing, it's all good. We have a laugh, we get help, and yeah, it's just generally a nice place to be. See you later. Thanks a lot. Bye.